This is Euclid Book 6, proposition number 30, and I got you guys a real precise number this afternoon, and I'll explain why in just a minute. But anyway, we're going to go ahead with the proof here. It says, to cut a given finite straight line in extreme and mean ratio, let AB be the given finite straight line. Okay. AB here is be the finite straight line. Thus it is required to cut AB in extreme and mean ratio. We'll get into that in just a second here. On AB, let the square BC be described. Well, the square they're talking about is A, B, H, and C. This whole big square right here. Okay. And let there be applied to AC the parallelogram CD. Well, the parallelogram CD is actually C, F, D, and whatever else letter you want to call it here. That one right there. It has to be equal to BC. Okay, the area inside here has to be equal to CHAB, that area right in there. Okay. And exceeding by the figure AD similar to BC. Okay, the figure AD is actually AED, this one right here. This is the exceeding part. And it has to be similar to BC. Okay, so it has to have a ratio similar to this. Okay. And this is by Euclid Book 6, proposition number 29, which was the last proof we did. Okay. Now BC is a square. Okay. Therefore AD is also a square. Okay. And since BC is equal to CD, BC up here, CD is this. Let CE be subtracted from each. CE, so we're going to have CFEA, this whole area here is going to be subtracted from the big square and from this big rectangle. Therefore the remainder BF, well, that would be B, E, F, and H, this one right here, this rectangle right here, is equal to the remainder AD, which is down here. Okay. But it is also equal angular with it. Therefore, in BF AD, the sides about the equal angles are reciprocally proportional, which is by Euclid Book 6, proposition number 14. Okay. The sides about the equal angles. Well, here's BF and here's AD. And here are equal angles right here. They're reciprocally proportional. Okay. Therefore, as FE is to ED, as FE is to ED, so is AE to EB. AE to EB. But FE is equal to AB. FE is equal to AB. And ED to AE. Okay. ED is equal to AE. Therefore, as BA is to AE, as BA is to AE, so as the big line here is to this little line, so is AE to EB. So is AE to EB. No, I'm sorry. Okay. So as BA is to AE, so as BA is to AE, so is AE to EB, which we've already established. That was stupid. And AB is greater than AE. Well, obviously the big old length of AB is bigger than the length of AE. Therefore, AE is also greater than EB. We just established that AE is greater than EB. Therefore, the straight line AB has but cut in the extreme and mean ratio at E, and the greater segment of it is AE. Now, you say, well, what was this precise measurement you were trying to get? Okay, well, in order to draw this proof correctly, you have to have some precise numbers. And I know I'm going to get some grief on this, okay? I have a 2-inch square up here. CH is 2 inches. CA is also 2 inches, okay? And we have down here, if I recall correctly, I'm going to measure this just to make sure I've got this all correct here so you guys can see this. Yep, I was right. I made this length right here 1 and 1, oh, not half, quarter, sorry, scribble that out. So let's just scribble that out. 1 and 1/4. Okay, so every one of these sides is 1/4. Now, here's what I'm going to hear. Well, gee, technically speaking, these areas you were talking about are not exactly precise, because if you were to take 3 1/4 times 1 1/4, you would get 3.99 whatever, which is not exactly 4, which is the 2 by 2. You are precisely correct. So, just to end your arguments, the number you really want is 2 plus 1 and 61 over 256. I'm not kidding you. If you add the 2 plus the 1.1 and 61, 256, and then you multiply that by 1 and 61 over 256, you will get exactly 4, which is this. Okay? And I'm going to hear it again. Well, it's exactly 4 until you get to like the 3rd or 4th decimal place. Okay, we're not going to, let me say, we've already gotten this precise. We're not going to go any more precise than this. Alright? If you got a ruler that's that good, let me tell you something. Anybody that has a ruler that's that good, I will personally give a shout out to anybody who can draw this within the nth degree. I mean it. I will absolutely give somebody a shout out for doing this. I'm not kidding you. You do that, and I will give you a shout out. But I don't know of any ruler out there that measures in the degree of 256. But if you have one, by gollies, I will give you a shout out right here on YouTube. Now, to show you how this thing actually works, okay? It was saying as FE is to ED. Well, okay. Let's go back here. We have FE to ED. Now, going by the numbers I was going to go with, alright, FE ended up being 2. I'll write this down. And ED ended up being 1 1/4. 1.25. So is AE to EB. Well, AE is, of course, 2. And EB ended up being 3/4. Well, no, wait a minute. Nope, I got this wrong. Hang on. AE is not that. AE is actually a 1 1/4. And this is 0.75. So, if you were to do the arithmetic on this, and you are more than welcome to do this, and I'll do it for you just because I'm such a nice guy. I really am. You suckered me into this. Alright, 2 divided by 1.25. Yes, I'm lazy, okay? That gives you a ratio of, gives you a number of 1.6. Well, 1.25 divided by 0.75 gives you 1.6 approximately, okay? It's so dang close that I won't even get into that. But there you go. There you have it. you can do the rest of the math all by yourself. You'll see that everything I said was true. And like I said, if you have a ruler that is that precise, I will give you a shout out here on YouTube. I absolutely will. I will refer people to your video because I figure you earned it. But anyway, that's as close as you're going to get to Euclid Book 6 proposition number 30. I hope you learned a few things. Now, the secret to drawing this, alright, the secret to drawing this is actually in Euclid Book 2 proposition number 11. If you want to draw this as properly as you can, go back to Euclid Book 2, proposition number 11, and you will be able to draw this. I'll say that one more time. Euclid Book 2, proposition number 11 will allow you to draw this. And there you go. I'll tell you more in a future video, so stay tuned.